Hello, my fellow scholars. I hope you are doing pretty well. In today's video, we are going to learn about end-to-end deployment. I'm going to create a TensorFlow model, get a very good accuracies, more than 90% for a couple of animal images, and then we will try to deploy it to a website where a person can go ahead and upload his or her own images and see the prediction of the backend model. And everything is going to happen real time. So as you can see on the screen, this is a kind of UI that is being created out from the Streamlit app, and we will go to this browse file and let's upload one of the image. So I'm going to upload a dog image over here. First of all, it is going to read up that image and show that image on the screen. Right now you can see it, and let's click on generate prediction. And once you will click on the generate prediction, it is going to call that model on the background, and that model will read out this image and generate the label for that image. As over here it is saying that predicted label for the image is dog, and this model is trained for not only for 4 and 5 up to 10 animals images, and we have used around 20,000 images to train up this model. And this is a quite good model. You can see, let me download couple of images from internet and show you how the model is performing. So I have already downloaded a couple of images with different resolution, and let me download couple more. So here we are. Let me download this spider image. So here I am downloading the spider image. It's done. Let me take this. This is actually, let me take this one. And let me take little bit complex one also. So like this one, and see how the model works out. And I'm pretty much not sure that our model will be able to recognize it, but let's take this one also. So download it. Now let's go to Streamlit and try uploading these images. Let's take the complex one first, and it is showing it up. Here it is. Let's click on generate prediction and let's see how it comes. Wow, so you can see that it is able to detect this one. Let me try out with some other images. So we have a hen image with egg, and see if that also works out. So guys, you guys can see that these are different resolution images. So you can see the earlier image was having different width and height, and this is different. Now let's generate the prediction. So you can see the model is quite robust and it is predicting everything pretty well. So here I'm going to keep it little bit fast forward and show you that if it is able to predict all the images pretty well. Yep. I have already shown you how the front end is coming out and how it is talking with the model on back end. Now we will try to code this complete pipeline from scratch. So I'm going to create a model from scratch, and then we will deploy this model to this Streamlit app, and I will also tell you that how you can host your website with Streamlit and have your model running on background, and the user can go ahead and use this model anytime wherever he wants. So first thing first, let's talk about the dataset. So we are using this animal 10 dataset over here, which is available within Kaggle, and thanks to the developer of this dataset, he has taken around 20,000 images of animals within this dataset, all with the mapping. So whenever you go to the Kaggle, logging to your account, check out this animal 10 dataset. I have added a direct link to this dataset in the description of this video, and you can go ahead and download this dataset. There is a problem with this dataset that it is having the names in not in English. So the developer of this dataset has also provided a translate.py script which contains a dictionary of all the labeled images, their English name and the other language name. Once you have downloaded this dataset on your local drive, because I do not have a big end GPU available within my laptop, so I'm going to use the Google Colab notebook for training up our model on GPU. So once you have downloaded this dataset, you need to just go ahead and upload your dataset on Google Drive. And inside Google Drive, you can create a folder named as animal classification. So this is the same account on which I used to create all video lectures. So let me create a new folder over here named as animal classification. And within this folder, so this is the archive file that I got. So I'm going to upload this file within this folder. Meanwhile, this data is uploading to our Google Drive. We are going to have our Google Colab ready to play with this dataset, and we are going to create a new notebook over here, and within this notebook we will be having, at first, since we are only developing writing up the code, we are not going to have a GPU instance because nowadays Colab has kept a limit on your GPU uses, and if you are not using GPU for a long time, it will start popping up those warnings that you are not utilizing GPU. So we will go to the runtime and change the runtime to none. Okay, since we are just going to test out or write out the basic script and create our dataset ready for the model ingestion or the model training. So guys, we have already uploaded our dataset in the Google Drive. Now this is the time to start our code. So we will be importing some of the basic libraries like OS. We will have to import Tensorflow, HDF. Now we need to import some yep. So instead of writing up our own architecture over here, we will try to use the previously created MobileNet architecture that we have used in couple of our other videos in this YouTube channel, and we already found that it performs pretty well, and the size of the saved file is also pretty small. So we will import that model from TensorFlow, keras dot applications dot mobilenet. Yep, I'm going to import the v2 version over here because I have a good feeling about this model from my past experience that it is pretty small. So we have written it incorrectly. We have to write from import mobilenet v2. As we all know that these sort of transfer learn model, they have their own pre-processing function, so we need to import that pre-process input also from the same library. Now we will be needing some of the layers, so let's import those layers. Okay, tensorflow dot keras dot layers import. So we'll be needing our usually dense layer, and we will be using con2d. We will be using global average pooling 2D, and if I'm missing something, yep, input layer. Yep, that's all. So all these layers now we will be using, because we need to early stop our model whenever we get a good validation accuracy. So we'll be using some of the callbacks. So let's import those callbacks. Keras import callbacks, and we'll be using the optimizer also. So import the optimizers. We imported TensorFlow, we imported OS. Yeah, we will need NumPy as NP, as we need to mount our Google Drive to this instance. So we will import Drive from Google Colab. Okay, I just wrote Google incorrectly. We'll see if any package will be required in future. Okay, from. Now the next thing we need to do is we need to mount this. So we'll write drive.mount, and here we will give content slash drive. Once you'll click on this link, it will ask for the authorization code. Go to link, log into your account, and you will get this authorization code. Paste it here and your drive will be mounted. So let's see where we are. We can do, as it is running on the Linux, so we can do /ls, and you can see we are within the drive and it is showing drive and sample data. Here we will be using the magic command to get into the drive slash my drive slash our animal classification folder that we just created. Run this, and now you are within the animal classification. So once you are over here, you have already uploaded your file. So now you just need to unzip the file. So we'll be using unzip, and then we have archive.zip. So you can see that I can run all the Linux command with this slash in the front, and once I will run this, it is going to unzip all the files. So as you can see, it has started unzipping all the files. And guys, this is going to take up some time because it's a huge folder. We have a lot of images saved within that zipped folder. So I will leave my laptop to run this command and will be back in a while once it is done. So guys, as you can see, all our files are now inflated or unzipped. This is the time to check out how the files are looking like on our Google Drive. So we are going to log into our Google Drive and see how the files are coming up. So right now, as you can see, we have this raw img file over here. Once I'll open this file, you will have all the folders. So we have all the folders over here. You can see we have all the animals name, and inside these folders we have those images saved. Yep, you can see for dog we have these all images. So our files are coming up pretty well. Now the only thing is that we have also this translate.py, and if I open this translate.py, you will be able to see that it has a dictionary which has the name mapping like cane to dog, cavalier to horse, elephante to elephant. So these are mappings we will be using to change these directories names. So the first thing we need to do, we need to write up a small Python function which is going to use this dictionary and change all the file names within that folder. Now this dictionary have some issues and I'm going to talk about those issues in a while. So let's clean this up. Now I'm going to comment this out so that we do not run this code multiple times. Now this is time to write up a small Python function to change those directory names. So we'll be using OS. So we will be using OS. So let's write up a for loop for that. For I in os dot list dir, and inside that we have raw files because we have seen that folder name is raw. The folder name is raw img, so we'll write that raw slash img. Let's print this out. So you can see all the folder names are coming up over here. So these are directories are there within this folder. So now as we want to change these file name based on those dictionary, so let's import that dictionary. So we can do import translate. So we can do from translate import translate. So this is the name of that file, that Python file that got created once we extracted this folder. We are importing this dictionary from this file. So let's see how this dictionary looks like. So eventually you can see this dictionary. Now let's talk about the problem with this dictionary. It has an issue with the keys and the pairs of the dictionary. So right now you can see the butterfly is mapped to Farfalla. In the next slide you have cane mapped to dog. So whereas butterfly is the English name and Farfalla is the other language name, here they are keys and values. In the other ones, they are values and keys. So dog is on the other side. So this is some sort of problem, and I tried to change some part of this translate.py, but I do not wanted to have this file to give it to you and then you try on top of that. So we will do some sort of cleaning on this script over here. So we will use os.rename. We have raw /img, and inside that we have this plus I. So this is the directory name that we wanted to change, and we have the name that we wanted to give, that we can write here, raw /img. Now this translate dictionary we'll use over here, translate, and inside that we will give this I. So what is going to do that, it is going to read out those names and then it is going to rename those files. But the problem with this dictionary is that it is not going to rename it correctly. So I tried it multiple times and just figured out that there are two names which are incorrect within the folder. So I'll just write up a small code for that. So we have, let me just first print this out, the name of the files within this folder. And Scottitluto, sorry for my pronunciation, it's not that great. So let me just rename this file. So this I'm going to do it independently. Meanwhile, in other case, what you can do, that you can go to this translate.py and change this file name itself, or change this dictionary itself within that folder, within that file. Now here, instead of the I, I'm going to give Rango. I could have done it here itself. Now this Rango, I wanted to give name. If you see what is the dictionary, so we have the Rango, yep, R-A. So if you see, it's Ragno, R-A-G-N-O over here, and it's Ragno, and it's on the value side actually. So it is actually a spider. So let me just paste it from here and add it on here. It is spider. Now the other thing that we need to change is the Tortillito. Sorry again. Let me just paste it over here and let me just change it from, if you see our dictionary, it is squirrel. So I'm going to copy the squirrel and paste it over here. So these files may come in between, so we will put up a try and except over here. So we'll have try except exception as E, print E. Let's run this. So you can see it has thrown up an error. Now what it is saying, that seems like we do not need to change this Tortillito because it must be okay, it's already there. So we can just comment this out and let me just check how the files are looking now. So I'll do ls, then raw img, and this is going to return me all the file names. So you can see butterfly, cat, chicken, cow, dog, elephant, horse, sheep, spider, squirrel. So it has done its work. We have all the files now in its English version. The next we are going to do that we are going to split this complete dataset into train and test. So right now we are all having these images in straight down within this folder, and also we wanted to calculate how many images are there because we do not want to have unbalanced sort of data set for model training. Let's do a sort check over here for I in. So I'll just copy the code from here to down there. Now for each individual directory we wanted to check how many files are there. So we'll do for j in os less dir plus, we'll put up a slash over here, I. So what it's going to do that it is going to go inside individual folder, and there we will print out the length of, okay, we do not actually have to iterate. So what we can do, we will do length of os plus dir. So this is we are going to print out, and what I will do, I'll also print out the I over here, sorry, the I here. Now this is going to print out the directory name and the number of file within that directory. Let's run this. Okay, we forgot to put up a bracket. Now run this. You can see we have, for dog we got 4863 images, whereas for couple of others we have only 1000 images, and there are a couple, for elephant we got only 1446 images. So we do not want to miss out any part, and according to me 1446 images, and I do not want to waste a lot of time in model training, is good enough to have in each folder. I'm going to delete all those images which are more than 1446. So inside every single folder I'm going to keep only 1446 images because I do not want unbalanced sort of dataset while model training. So there are issues with the models when you will have unbalanced sort of datasets. In a vague sense, you can say if you got one class which is having a humongous amount of images and the other class which is having a very less number of images, for an optimization algorithm, it is just like it has to reduce the total error. But your data set is not balanced, so your model will be biased towards the class which is having higher number of images. So always make sure that you are having equal number of images for each individual class, or a very slight variation in number of images, because obviously you do not want your model to get biased on one class. So that's what we are doing over here. We are going to remove all the images which are higher than 1446. In each individual folder, we are going to keep only those number of images. So guys, firstly, we were thinking to clean this folder itself, but what we can do that we can have the data splitted into train and test, and at the same time we will only take 1000 images for model training and around 400 or 400 approx images for model testing. In that way we will have a good sort of split. So let's do one thing. We are going to split our dataset into train and test, and for that we will need to create a train test directory. So I'm going to write os.mkdir. This is going to create a directory train, and same I'm going to do with the test. And inside those directories, what we want to do that we wanted to get into the folder of raw image and take first 1000 images in the train side and then 400 next images on the test side. So we'll write up a loop over here. So that loop will be like this only. So now you know that we are getting into dog, horse and elephant. So same sort of folders we need to create inside the train and test folders. So we will just copy this train command from here, and here we will write slash plus I. So this is going to create the folder within the train dataset, and the same thing we are going to do with the test one. So now we will have all dog, horse, elephant, all these sort of folders created within our directory. Now here we want to iterate also within the directory. So we will have another loop inside that for j in os list dir. Let me copy this one. And this one we are going to iterate folder by folder. So we'll have slash and I. Now this time we wanted to go first 1000. So we'll have 1000 till 1000. We'll go over here, and here this is going to iterate on the first 1000 files within that folder, and here it is going to create or move the file from my raw image. Let me just write this down. Raw image slash I slash j. So this is a complete path, raw image plus ith folder plus jth image, and here we wanted to move this to our train site. So we'll have train here, train plus ith folder plus jth image. Now once this is done, the first 1000 images within that folder will be moved. So what is going to happen, that suppose it got 1200 image within that folder, you have removed the first 1000 image. So now only 200 files will be remaining within that raw folder. So appending up the logic, what we will do, that we will take next 400 images from here and we will move that to the test folder. So here instead of the train, we will just write test. It's quite straightforward. What is going to happen, that first it is going to look at those 1000 images, move those files into the train one, and now apart from the 1000, the remaining files will remain within the raw image folder. Now it is going to check the next remaining images, which are about 400. So this I took because we have the least number, about 1446. So out of those, if I remove 1000, we will have 446, and this is the lowest amount of image that we have. The remaining 400 images that we are going to move into the test folder. Now hope we are very well done this one. So let's run this and hope this is going to copy everything. No, we got an error. So where is the error? Yep, so we got error because we didn't add the slash. So we need to add a slash over here, and same thing we need to do on this part, and same part we need to copy over here, over here. Okay, the path is coming correctly. Let's have a look again. So we have ith plus slash plus j plus ith plus slash plus j image test. Okay, let's run this. Now see what happened, that we ran that code earlier, so it has created those folder in the first try. So we are going to get this error multiple times because those folders are already created within that directory. So for surpassing that error, I'm going to put up one try and accept, and I know that what will be the error, so I'll just put accept pass over here. And same thing is going to happen with these directories because we have these are already created. So we'll put try and we will put one accept, and we'll just pass once because we know that the error will be just that we already have a directory over there. Let's run this and see if our files are getting moved. Looks like it's working, and our files are getting moved into train and test folder. This is the only sort of pre-cleaning required for model training. Once you are done with this, we are good for writing up the model code. So guys, here our training and testing images are splitted, and if you want to check, you can do ls test, and this is showing that you have those folders created within the test folder. And you can also confirm by going to your drive, and you will have train test folders over here, and you will have images saved within these folders. Now it is still opening up. Yep, you can see the images. Now here comes the main modeling part. So what we are going to do, that we first have to use image data generator, and I think we haven't imported it earlier, so let's import it. So from tensorflow dot keras dot pre-processing inside image import load image and image data generator. Yep, let's run it again. I think, okay, this is, I don't know how it's got there. Let's run this. Yeah, so we have the image data generator now. So we have discussed a lot about the image data generator in my other videos. I'm not going to talk a lot. It's just for creating a labeled dataset from those directories. So how to use it? We are going to create two generators, one for our training and other for our validation. So we are not going to have a testing sort of over here, because we will be utilizing those two generators to train up. At the same time, we will use it the other one as in validation. And since we are more focusing on the deployment side, I am not going to talk about the model diagnosis. As we want to use this generator 2-3 times in real life, we will have three splits: one for training, other for validation, other for testing. So basically we usually create a function for this image data generator. So let's create a function for this one, def image data. I'm going to give this name. We'll write the arguments after writing it up. Since we are using a transfer learned model MobileNet over here, we will be using a pre-processing function. So let's put up an argument on this one named as pre-processing CSSing. Pardon if I'm just writing up a typo, it's just a variable name. So this image data generator, I want to keep it versatile. So what I will do, if pre-processing is true, then we will have an generator object defined, which will be the image data generator, and inside that we will have, so you can see it, we have a pre-process argument over here, and this pre-processing function we are going to pull within this one, or else we are going to have this generator object without the pre-processing function. So we will have a simply defined generator object. Now we will write gen underscore object. Let's define it so that we will get the argument. So what I'm going to do, I'm just writing it over here. Now this gen object, it will be faster to code out because we will be getting the helping argument. So we have to use flow from directory, because all our data is saved in form of directories, and inside that you can see we need to give the directory path. So I'm going to give dir path. Now the other thing, we need to give the target size. So let's put it target size, and the other part we need to put is the batch size. We will just keep it. So right now I am defining it, and I will just put it in on the top over here, because we want to use this function 2 times for training and validation dataset generator. Now after this batch size, we have the class mode. So class mode, so this we are going to keep it sparse only. Now we will have class list. So this will also be the argument of this one. What we can do, let me just split it down. Is equal to class list. This one we will, let me just change this lst we can do. This will keep it at an argument, and ffle shuffle is equal to true. I'll just take this. And this complete thing we are going to return from here. Yep, I think we are good in shape. Let me just pull it all together so that it's looking up good. Batch size, class mode. All these arguments we are going to put over here. So directory path, target size, then we have batch size, batch, then we have class list, and let's do this. Basically the first argument, so do not have to run this. So you can see that our function is being created. Let's test this out with calling the train data generator gen. Now we will call this function, and inside that we will give the directory path, which is train, and the second thing we need to give the target size, that is, since we are using a transfer learned model over here, for transfer learned we have to give 224 cross 224. So these are the defined size for mobile net. We can have other size for other sort of models, but right now we are using mobile net, that's why I'm giving this. Then you have to give the batch size, as we have 1000 images, or yeah, more than 1000 approx images, so I want to give a huge batch size around 500. And since we'll be using GPU, it is okay to give. Now we will have to give the class list, and here in the class list I'm going to give the list of files within the directory. So we'll just use list dir, and inside that we will do train. Now after this we need to give the pre-processing. Okay, I missed this out, we have a wrong comma over here. So the pre-processing function, we are going to use the MobileNet pre-processing function. So I'll just copy it from the top. Here we have taken this pre-process input, and let's give this pre-processing function over here. Okay, let's test this out. Okay, we have kept it within the else, so we just need to take it out from the loop and run this. Since we do not have something, we have some, it is known as classes. Let's test this out. Yep, you can see it is working pretty well, and we have our train data generator ready for model training. Or in the same way, we'll have our validation data generator, valid data gen, and I'm going to take this complete thing, paste it out. Instead of train, I will have test, and here again I will have test, and I will run this. So you can see we have splitted our data set, and we have 10,000 images for 10 classes, and we have 4,000 images for 10 classes. And this is a fully balanced data set because for every individual class we have 1,000 images. In a long shot, we are good with model training data. We have prepared all data set, and this is the time to define our model. As I told earlier, we are not going to create any architecture. We are going to take up the MobileNet v2 architecture, and I'm not going to write the code. I will just do a Google search. Yep. So I'll just take this out from here and I'll just paste it over here, and I will just write this down, base model. And this is the way we define transfer learned model in a simplest way. So let me just create. So we'll be using this architecture for our own dataset. So we need to remove the top layer. So we'll put false over here, and other aux we will remove this key aux from here. Softmax is correct. Now we do not need the classes. Let it be there. And this way we have our base model defined. So one thing to call out over here, we have to give the input shape, that is 224 comma 224 comma 3, and yep, let's run this. Yeah, we are good. Now we do not want to train the layer of this model, so we'll just freeze this. So that can be done with the trainable argument, and we will put this as false. So what this is going to do, that it is going to freeze all the layer training for this base model. We are going to put some additional layer on top of this model, and we will only train those layers because it's a very big network, and we do not want to train each individual node of that network. So let's add some layers on top of this base model. We can have a model defined. So tf dot keras dot models dot sequential. Now we will add model layers, so we'll add this one, model dot add, and we'll just add our base model to this model. You will have this base model attached to your model. Now we can easily add layers on top of this one. So whenever, if you see the summary of this model, let me just print this out. Summary. It's a big model, and if you see the last layer, it is having 7 cross 7 cross 1280. So we have a out value which is giving this big tensor out, and we want to map this tensor to the 10 classes which are there in our dataset. So we will add some basic layers on top of this model. The first one, we wanted to have the global average pooling. So I'll just go ahead and I'll just copy this global average pooling 2D to our model over here. Yeah. So this is done, and meanwhile, we have to put a bracket over here, and this is done. And while adding up the layer, we'll keep on checking the model summary. So you can see our global average pooling has reduced all those 7 cross 7. Now we have only 1280 comma none. Now this can be mapped. So can have the dense layer now on top of this. Okay, we wanted to keep this in power of 2. So let's keep 1024. That I have tried earlier and it worked pretty well. Let's see how it works here. And we have to put the activation, and that is will be ReLU. Now once this is done, now add up a softmax on top of this one, and that softmax should return us 10 classes, and the activation should be softmax. So let's see how the summary looks like. Yep, so you can see we have 10 classes in our image dataset, and we are getting those ones, and this is coming from 120 to 1024. That is okay, but we have a humongous amount of parameters over here, and all these will be trainable, and you can see the trainable parameters are around this one summed out to this one, and all the other parameters from the base model we have freezed them. And this is a way most of the people try to use transfer learning within that model, but there I have seen couple of people freezing some amount of layer from the base model and keeping some amount of layers trainable. That is also workable. Compile the model, so we'll do model.compile, and here we are going to give the optimizer is equal to, let's give Adam loss. So right now we are using image data generator, so for that we usually use sparse categorical cross entropy, and I have already explained what is the meaning of sparse categorical cross entropy in my other videos. If you wanted to check out those videos, I have given link in the description, and you will have clear cut idea that why we keep this sparse or sometimes categorical cross entropy, sometimes something else over here. Now the last part, matrix. So we have done some typo. Run this. Seems like our model is now compiled, and this is the time to have some. So if you recall from the top, we have imported some of the callbacks and the optimizers for our model early stopping and only saving the best model out. So there is a straightforward code. So you need to define two variables over here. So first one will be the ELST. So this is for early stopping. Just put this callbacks dot early stopping, and here we need to monitor the validation loss. So we'll just copy this argument from here and paste this out. Now how much patience you want to keep, how many iteration you want to wait. Patience will want to wait for 5, and mode is equal to, we want to minimize the loss. That's it. Okay, this should come within the quotes. So this is for our early stopping callback. The other will be, we wanted to create the checkpoint of the model after every iteration. So say ck checkpoint, and we want to change this to checkpoint, model checkpoint, and here we have to give some file path. So we'll be saving in the same folder, model waits wt dot sdf5. So here you can do two things. You can also save your file as an h5 format as well as an sdi format. Doesn't make any change, and you wanted to put save best only is equal to true, and you wanted to monitor the validation loss. Monitor, you'll have validation loss, loss, and mode will be the min, as you want to minimize the loss. Both our checkpoints are now created. Now it is not going to do overfitting of the models, and also going to save the best model based on the validation accuracy. The last part you have to do is model.fit, and once you are done, here you need to give the train data generator, and train data generator. Now batch size, we are going to keep the same 500. I think we have defined the same 500 over here, and then validation data generator, so that we have valid data generator over here, and you have to provide the callbacks bracket. Inside this we have to give those elst and the save ck. Now how many epochs you wanted to go? I wanted to go for 10 epochs. Let's check this is correct, everything. It looks like that. Run this. Here you can see the model training has started. So I'm going to leave this out over here and come back after some time while this model gets trained. So guys, you can see that the model has completed the first iteration and it got a pretty good accuracy, 72% on the training side. And this is quite surprising. We got very good validation accuracy even though the training was not that great. But still keep on training and let's see how better we can achieve. Now, since the first iteration is being completed, so our model would have been saved in the Google Drive. So let's go back to our Google Drive. So here we are. Yeah, you can see .model.weight.sti5. We will just download this file. And at the time, right now we are going to write the Streamlit application for our local environment from which we will be hosting up the web page. So we need some model to be there so that we can just test this out. So guys, here is a small code that I have written down to create the UI based on Streamlit, and this I will upload on the GitHub and I will give the link in the description so that you can just download this file and use it for your own. So I'll explain this code line by line, what is happening within this code and how the UI is getting generated. So let me go ahead and show you what our file this contains. So we have the saved model folder which have those saved weights from the Colab that we got after model training. And then we have requirement.txt. I think there is a couple of more requirement. We have CV2 also here. Uh, and let me just check. Yep, that's all. So you have also CV2 over here. So you have to run this requirement.txt and install all those libraries. I'll just add the details about this in the GitHub itself. We can use it without any issues. And let me show the main file now. So here is the main script. So what it is doing, that it is importing first all the libraries, and after that it is going to the model and it is reading up that model at the start. So here once that model is loaded within that model variable, then you have this st.file uploader. So guys, this what it is doing, that okay, before we get into this part, let me give a brief introduction about Streamlit. So Streamlit is made on Flask API, which creates server, and you will have a front end which is a website with a two lines of code. Actually this much part of the code itself has created your front end of that web page, and here it is saying that put up a file downloader box within that UI. Let me run it and show you. If you want to just check this out, I will just comment the complete code below to this one and show you how it is working. So right now I'm over here. So this is I'm running from the shell, and I have to just write streamlit run. So whatever is the name of, so it's a streamlit host.py, and once you will launch this, it is going to create a server, and let's see, it's running it. I think taking up some time. My computer is not so great. So this, once we have run this, you can see it has started running localhost, and you can get to this localhost by just one click over here, and you can see it's running over here. And only the part of the code that I have written, let me go back. So only this much part of the code was able to create a web page for you, and in this web page you can see the application is right now running, and it is right now loading up that model, and you will have this box created for uploading the file. And once you click on this box, you can see that it is giving you a dialog box for uploading your files. So very straightforward to create the application. Now the second part of the code is we have a map dictionary where I have all those model maps which are like 0, 1, 2, 3, 4, 5, 6. So these are the simple mapping of those of that image data generator that we have used, because we know that it converts categorical variables into numbers. So this is the mapping, and here if you go down, yep. So here if you go down, once you have clicked on that dialog box, you have selected a file. So this uploaded file have that variable or that file saved within that. Now if it is not none, it has to go down and it is going to read up with the CV2. And this code actually is very straightforward and can be found in the GitHub repo. And within this code, so once we have read out the file, we are resizing the file to the desired shape. So we know that our model takes 224.224, so that's why we are resizing our image to that shape. Now once this is done, you are just showing that image to the Streamlit window. So whenever you wanted to show something within the Streamlit window, you have to write st.image, and after that you need to give that image and the channels. So this image is the CV2 image that is loaded over here. So I just wanted to show that we are using different aspect ratios image. That's why we haven't shown the resized image within this st.image. Instead of that, we are showing the original image over here. Now, once this is done, we know that our mobile net architecture takes the image after the pre-processing being done with the mobile net pre-processing script. So we are directly doing the pre-processing on top of this resized image. And since we all know that it's a pretty straightforward that you need that extra access wherever you are generating the model predictions, because the time it got trained, you have a none dimension added to the model. So once this is done, you have a button over here saying that generate prediction. And once that button is clicked, it is calling up model.predict method and returning up the class using this argmax method. And you know that we have the index coming out with this argmax method, so we need to give the proper label, so that we are taking up from the dictionary, map dictionary that we have defined over here. It has map for each and individual index. So this is going to give you the label. So right now we just made the changes, and you can see that the changes would have happened. So if you run, if you click on the rerun, it is going to accumulate all those changes that you did with the script over here, and you will be able to, so it's a real time, like you do some changes with the backend code and it gets reflected over here. So if I will select the file now, like this horse one. Now you can see the horse image is coming up, and if you click on the generate prediction, it is going to generate, it is going to call out that model and then generate the prediction for this model. So all this code is available on my GitHub, link given in the description. If you like the video and if you want to check out more content like this, don't forget to press the like, share and subscribe button for this channel. I will catch up with you in my next video. Till then, bye bye and take care.